To increase the number of coded outputs beyond the Silent Night 5820XL capacity of 8, consider using an external power supply such as the Edwards ESP-4000 series power supply. This power supply supports up to 32 coded outputs and is compatible with the Silent Night 5820XL. For broadcasting fire alarm messages to maintenance personnel with portable radios, look into the Wheelock ESS Alert Voice Guard M4500 series. This system transmits audible fire alarm messages directly to portable radios. The system utilizes a dedicated low-frequency channel specifically for fire alarm communication. It's important to verify compatibility with the fire alarm control panel, as the Wheelock ESS Alert system is a proprietary solution. To ensure proper integration and compliance with codes and regulations, consult with a certified fire alarm technician to determine the specific requirements of the system. When selecting and installing fire alarm systems and components, several factors must be considered. Firstly, the building's occupancy classification and use must be determined, as this dictates the level of fire protection required by the applicable building codes. Secondly, the specific hazards present in the building should be identified, such as flammable materials or areas with limited egress, as these may necessitate specialized detection or suppression systems. Thirdly, the local fire codes and regulations must be carefully reviewed to ensure compliance with all applicable requirements, including those related to system design, installation, testing, and maintenance. Fourthly, the system's reliability and performance should be evaluated, considering factors such as the quality of the components, the system's ability to withstand environmental conditions, and the availability of backup power. Fifthly, the system's ease of use and maintenance should be considered, as this can impact its long-term effectiveness and cost. Sixthly, the system's compatibility with other building systems, such as HVAC and security, should be assessed to ensure seamless integration and avoid conflicts. Seventhly, the system's cost-effectiveness should be evaluated, considering both the initial investment and the ongoing operating and maintenance expenses. Finally, it is essential to work with a qualified and experienced fire alarm contractor who can provide expert guidance and support throughout the entire process, from design to installation to maintenance. When dealing with fire alarm systems, the National Fire Protection Association, or NFPA 72, the National Fire Alarm and Signaling Code, is a crucial standard to follow. This code provides comprehensive requirements for the application, installation, performance, and maintenance of fire alarm systems. It covers various aspects. Firstly, system design, including the selection and placement of detection devices, notification appliances, and control equipment. Secondly, installation practices, including wiring methods, conduit requirements, and grounding procedures. Thirdly, testing and inspection procedures, including periodic testing of all system components and documentation of test results. Fourthly, maintenance requirements, including regular maintenance of batteries, detectors, and other critical components. Fifthly, emergency communication systems, including voice evacuation systems and two-way communication systems for fire department use. Sixthly, mass notification systems, which are used to provide emergency information to building occupants in the event of a fire or other emergency. Seventhly, cybersecurity considerations for fire alarm systems, including measures to protect systems from unauthorized access and cyber attacks. Eighthly, documentation requirements, including the preparation and maintenance of system drawings, operating manuals, and maintenance records. The NFPA 72 code is updated regularly to reflect the latest technological advancements and best practices in the fire alarm industry. It is essential for fire alarm professionals, building owners, and facility managers to stay informed about the current edition of the code and its requirements. When working with electrical systems, adherence to the National Electrical Code, or NEC, is essential for safety and compliance. The NEC provides detailed requirements for the safe installation of electrical wiring and equipment. Article 760 addresses the installation of fire alarm systems. Some key requirements include: firstly, proper wiring methods, such as the use of listed and labeled cables and raceways. Secondly, overcurrent protection, including the use of fuses or circuit breakers to protect circuits from overloads and short circuits. Thirdly, grounding and bonding, to ensure a safe path for fault currents and to minimize the risk of electric shock. Fourthly, separation of fire alarm circuits from other electrical circuits to prevent interference and ensure reliable operation. Fifthly, emergency power supply, including the provision of a backup power source to keep the fire alarm system operational during a power outage. Sixthly, proper labeling and identification of fire alarm circuits and equipment. Seventhly, compliance with applicable listing and labeling requirements for all fire alarm system components. Eighthly, inspection and testing of the completed installation to verify compliance with the NEC and other applicable standards. The NEC is updated every 3 years to reflect the latest technological advancements and best practices in the electrical industry. It is essential for electricians, electrical contractors, and fire alarm installers to stay informed about the current edition of the NEC and its requirement. When designing and installing fire alarm systems, it is essential to consider the specific requirements of the Americans with Disabilities Act, or ADA. The ADA requires that fire alarm systems provide both audible and visual alarms to ensure that all building occupants, including those with hearing or visual impairments, are alerted to a fire emergency. Some key requirements include firstly, the provision of visual alarms in all public and common areas such as hallways, lobbies, and restrooms. Secondly, the provision of visual alarms in sleeping rooms in hotels, motels, and other transient lodging facilities. Thirdly, the proper placement and spacing of visual alarms to ensure adequate coverage. Fourthly, the use of visual alarms that meet specific performance criteria such as light intensity and flash rate. Fifthly, the coordination of audible and visual alarms to ensure that they are synchronized and provide a clear and understandable warning. Sixthly, the provision of accessible means of egress such as ramps and elevators to allow people with disabilities to evacuate the building safely. Seventhly, the training of building staff and the proper use of the fire alarm system and evacuation procedures for people with disabilities. Eighthly, the regular inspection and maintenance of the fire alarm system to ensure that it is functioning properly and meets ADA requirements. Compliance with the ADA is essential to ensure that fire alarm systems are accessible to all building occupants and provide effective notification of fire emergencies. To ensure the reliability of fire alarm systems, regular testing and maintenance are crucial. NFPA 72 provides detailed requirements for testing and maintenance procedures. Some key aspects of testing and maintenance include firstly, regular visual inspection of all system components, including detectors, notification appliances, and control panels. Secondly, periodic testing of detectors to verify their sensitivity and responsiveness. Thirdly, testing of notification appliances to ensure that they are producing the required sound or light output. Fourthly, testing of the control panel to verify its ability to process alarm signals and activate notification appliances. Fifthly, testing of the emergency power supply to ensure that it can provide backup power in the event of a power outage. Sixthly, cleaning of detectors and notification appliances to remove dust and debris that can impair their performance. Seventhly, replacement of batteries on a regular schedule to ensure that they are capable of providing adequate power. Eighthly, documentation of all testing and maintenance activities, including the date, time, and results of each test. Regular testing and maintenance are essential to identify and correct any problems with the fire alarm system and to ensure that it is functioning properly in the event of a fire emergency. Maintaining accurate and up-to-date documentation of the fire alarm system is essential for effective management and maintenance. Documentation should include firstly, system design drawings, showing the location of all system components and wiring diagrams. Secondly, equipment specifications, including model numbers, serial numbers, and manufacturer's information. Thirdly, installation records, including the date of installation, the name of the installer, and any modifications or repairs that have been made. Fourthly, testing and inspection records, including the date, time, and results of each test. Fifthly, maintenance records, including the date, time, and description of any maintenance activities that have been performed. Sixthly, operating manuals, providing instructions on how to operate the fire alarm system. Seventhly, emergency contact information, including the names and phone numbers of key personnel who should be contacted in the event of a fire emergency. Eighthly, a written fire safety plan outlining procedures for evacuating the building and responding to a fire emergency. Accurate and up-to-date documentation is essential for troubleshooting problems, performing maintenance, and ensuring that the fire alarm system is functioning properly. It also provides valuable information for fire investigators in the event of a fire. The Edwards ESP-4000 series power supply offers advanced features for fire alarm systems. It provides, firstly, intelligent power management, automatically adjusting output voltage and current to optimize system performance. Secondly, network communication, allowing the power supply to be monitored and controlled remotely. Thirdly, battery monitoring, providing real-time information on battery status and performance. Fourthly, diagnostic capabilities, allowing technicians to quickly identify and troubleshoot problems. Fifthly, programmable outputs, allowing the power supply to be customized to meet specific application requirements. Sixthly, multiple voltage outputs, providing power for a variety of fire alarm system components. Seventhly, surge protection, protecting the power supply and connected equipment from damage due to voltage surges. Eighthly, compliance with UL standards and other applicable codes and regulations. The Edwards ESP-4000 series power supply is a reliable and versatile solution for powering fire alarm systems. The Wheelock ESS Alert Voice Guard M4500 series is a specialized communication system designed to enhance fire safety in buildings. It enables, firstly, direct voice communication with building occupants during a fire emergency. Secondly, targeted messaging, allowing specific instructions to be delivered to different areas of the building. Thirdly, integration with the fire alarm system, automatically activating the voice communication system upon fire alarm activation. Fourthly, remote control, allowing fire department personnel to control the voice communication system from a remote location. Fifthly, pre-recorded messages, providing clear and concise instructions to building occupants. Sixthly, live voice announcement, allowing fire department personnel to provide real-time updates and instructions. Seventhly, two-way communication, allowing building occupants to communicate with fire department personnel. Eighthly, compliance with UL standards and other applicable codes and regulations. The Wheelock ESS Alert Voice Guard M4500 series is a valuable tool for improving fire safety and facilitating effective communication during a fire emergency. Integrating a fire alarm system with a building shortwave radio system presents significant technical and regulatory challenges. Firstly, the use of shortwave radio frequencies is heavily regulated by government agencies, such as the Federal Communications Commission, or FCC, in the United States. Secondly, the potential for interference with other radio communication systems is high, which could compromise the reliability of the fire alarm system. Thirdly, the range and coverage of shortwave radio signals can be affected by various factors such as atmospheric conditions and building construction. Fourthly, the security of the communication channel must be ensured to prevent unauthorized access and interference. Fifthly, the system must be designed to meet the specific requirements of the building and its occupants. Sixthly, the system must be tested and maintained regularly to ensure its proper operation. Seventhly, the cost of implementing and maintaining such a system can be significant. Eighthly, alternative communication methods such as cellular or satellite communication may be more reliable and cost-effective. Before considering integrating a fire alarm system with a shortwave radio system, it is essential to carefully evaluate the technical, regulatory, and economic implications. It is also important to consult with qualified professionals who have expertise in both fire alarm systems and radio communication systems. Ensuring compatibility between different fire alarm system components is crucial for reliable operation. Compatibility issues can arise from, firstly, different manufacturers using different communication protocols. Secondly, different components having different voltage or current requirements. Thirdly, different components having different wiring configurations. Fourthly, different components having different software or firmware versions. Fifthly, different components being designed for different types of fire alarm systems. Sixthly, different components being installed in different environments. Seventhly, different components being subjected to different levels of stress or wear and tear. Eighthly, different components being maintained by different personnel with different levels of expertise. To ensure compatibility, it is essential to firstly consult with the manufacturers of the different components. Secondly, review the product specifications and technical documentation. Thirdly, perform compatibility testing before installation. Fourthly, use only listed and approved components. Fifthly, follow the manufacturer's instructions for installation and maintenance. Sixthly, ensure that all components are properly grounded and bonded. Seventhly, provide adequate power and ventilation for all components. Eighthly, train personnel on the proper operation and maintenance of all components. Addressing potential issues with expanding the number of coded outputs in a fire alarm system requires careful planning and execution. Firstly, verify the existing system's capacity. Determine the maximum number of coded outputs the current fire alarm control panel, or FOCU, can support. Secondly, evaluate the need for expansion. Assess the specific requirements for additional coded outputs based on the building's layout, occupancy, and fire safety plan. Thirdly, select a compatible expansion module. Choose an expansion module that is compatible with the existing FOCU and meets the required number of coded outputs, such as the Edwards ESP-4000. Fourthly, ensure proper power supply. Verify that the power supply is adequate to support the additional load of the expansion module and the connected devices. Fifthly, follow wiring and installation guidelines. Adhere to the manufacturer's instructions and relevant codes and standards for wiring and installing the expansion module. Sixthly, test and verify functionality. Thoroughly test all coded outputs and connected devices to ensure proper operation and functionality. Seventhly, update system documentation. Update the fire alarm system documentation, including wiring diagrams and zone maps to reflect the changes made. Eighthly, train personnel. Train building staff and maintenance personnel on the operation and maintenance of the expanded fire alarm system. Several key factors determine the cost of installing or upgrading a fire alarm system. Firstly, the size and complexity of the building, which affects the amount of wiring, conduit, and other materials required. Secondly, the type of fire alarm system, with addressable systems typically being more expensive than conventional systems. Thirdly, the number of detection devices, such as smoke detectors, heat detectors, and pull stations. Fourthly, the number of notification appliances, such as horns, strobes, and speakers. Fifthly, the need for special features, such as voice evacuation, smoke control, and elevator recall. Sixthly, the labor costs associated with installation, testing, and commissioning. Seventhly, the cost of permits and inspections. Eighthly, the ongoing maintenance and monitoring costs. To minimize costs, it is essential to firstly, obtain multiple quotes from qualified fire alarm contractors. Secondly, choose a system that meets the specific needs of the building without unnecessary features. Thirdly, consider the long-term costs of maintenance and monitoring. Fourthly, ensure that the system is properly designed and installed to minimize future problems. Regular training and certification for fire alarm technicians are essential for ensuring the safety and reliability of fire alarm systems. Training programs should cover firstly fire alarm system design and installation. Secondly, testing and inspection procedures. Thirdly, maintenance and troubleshooting techniques. Fourthly, relevant codes and standards such as NFPA 72 and the NEC. Fifthly, specific product knowledge for different manufacturers and models of fire alarm systems. Certification programs should firstly verify the technician's knowledge and skills through written and practical exams. Secondly, require continuing education to stay up to date on the latest technologies and best practices. Thirdly, be accredited by a recognized organization such as the National Institute for Certification in Engineering Technologies, or NICET. Certified fire alarm technicians are more likely to firstly, properly design and install fire alarm systems. Secondly, accurately diagnose and repair problems. Thirdly, ensure compliance with relevant codes and standards. Fourthly, provide reliable and effective service to building owners and occupants. The legal liability associated with fire alarm systems can be significant for building owners, property managers, and fire alarm contractors. Building owners and property managers are responsible for firstly, ensuring that the fire alarm system is properly designed, installed, and maintained. Secondly, complying with all applicable codes and standards. Thirdly, providing adequate training for building staff on the operation of the fire alarm system. Fourthly, taking prompt action to address any problems or deficiencies with the fire alarm system. Fire alarm contractors are responsible for firstly, properly designing and installing fire alarm systems. Secondly, using only listed and approved components. Thirdly, following the manufacturer's instructions for installation and maintenance. Fourthly, providing accurate and complete documentation of the fire alarm system. Failure to meet these responsibilities can result in firstly, fines and penalties. Secondly, lawsuits for damages in the event of a fire. Thirdly, criminal charges in cases of negligence or willful misconduct. To minimize legal liability, it is essential to firstly, hire qualified and experienced fire alarm contractors. Secondly, maintain accurate and up-to-date records of all fire alarm system activities. Thirdly, comply with all applicable codes and standards. Fourthly, promptly address any problems or deficiencies with the fire alarm system. Understanding the different types of fire alarm systems is crucial for selecting the appropriate system for a specific building and application. Firstly, conventional fire alarm systems are the simplest type of system, with each detection device wired directly to the control panel. Secondly, addressable fire alarm systems are more sophisticated, with each detection device having a unique address that allows the control panel to identify its location. Thirdly, wireless fire alarm systems use radio frequency communication to connect detection devices to the control panel, eliminating the need for wiring. Fourthly, hybrid fire alarm systems combine features of conventional and addressable systems, providing flexibility and cost-effectiveness. Conventional fire alarm systems are typically used in smaller buildings with simple layouts. Addressable fire alarm systems are typically used in larger buildings with complex layouts, as they provide more detailed information about the location of a fire. Wireless fire alarm systems are typically used in buildings where wiring is difficult or impossible, such as historic buildings or buildings with concrete walls. Hybrid fire alarm systems are typically used in buildings where a combination of features is required. Choosing the right type of fire alarm system depends on the specific needs of the building and the budget available. Integrating fire alarm systems with other building systems can enhance safety and efficiency. Firstly, integration with HVAC systems can allow the fire alarm system to shut down the HVAC system in the event of a fire, preventing the spread of smoke and fire. Secondly, integration with access control systems can allow the fire alarm system to unlock doors in the event of a fire, facilitating evacuation. Thirdly, integration with elevator control systems can allow the fire alarm system to recall elevators to the ground floor in the event of a fire, preventing them from being used by occupants during evacuation. Fourthly, integration with building management systems can provide centralized monitoring and control of all building systems, including the fire alarm system. Integrating fire alarm systems with other building systems requires careful planning and coordination to ensure that the systems work together properly. It is essential to consult with qualified professionals who have expertise in both fire alarm systems and other building systems. When planning a fire alarm system installation or upgrade, consider several key factors to ensure a successful outcome. Firstly, conduct a thorough risk assessment to identify potential fire hazards and determine the appropriate level of fire protection. Secondly, consult with local fire authorities to understand specific code requirements and obtain necessary permits. Thirdly, select a qualified and experienced fire alarm contractor with a proven track record of successful installations. Fourthly, develop a detailed project plan that includes timelines, budgets, and responsibilities. Fifthly, choose a fire alarm system that meets the specific needs of the building and its occupants, considering factors such as size, occupancy, and layout. Sixthly, ensure that the fire alarm system is properly integrated with other building systems such as HVAC, access control, and elevator control. Seventhly, provide adequate training for building staff on the operation and maintenance of the fire alarm system. Eighthly, conduct regular inspections and testing to ensure that the fire alarm system is functioning properly. Effective communication is crucial during a fire emergency to ensure the safety of building occupants. Fire alarm systems play a vital role in providing timely and accurate information to occupants, but it's important to supplement these systems with other communication methods. Firstly, voice evacuation systems can provide clear and concise instructions to occupants, directing them to safe evacuation routes. Secondly, two-way communication systems can allow occupants to communicate with emergency responders, providing valuable information about the location and nature of the fire. Thirdly, emergency notification systems can send alerts to occupants via text message, email, or mobile app, providing real-time updates and instructions. Fourthly, building staff should be trained on how to effectively communicate with occupants during a fire emergency, providing reassurance and guidance. A well-coordinated communication plan can significantly improve the effectiveness of fire evacuation procedures and minimize the risk of injury or death. The longevity and reliability of a fire alarm system depend on consistent and thorough maintenance practices. Firstly, regular inspection should be conducted to identify any potential problems, such as damaged wiring, corroded contacts, or malfunctioning devices. Secondly, detectors should be cleaned periodically to remove dust and debris that can impair their sensitivity. Thirdly, batteries should be tested and replaced as needed to ensure that the system can operate during a power outage. Fourthly, all system components should be tested regularly to verify their proper operation. Fifthly, detailed records of all maintenance activities should be maintained to track the system's performance and identify any recurring issues. A well-maintained fire alarm system is more likely to function properly in the event of a fire, protecting building occupants and minimizing property damage. Advances in fire alarm technology continue to improve the effectiveness and reliability of these systems. Firstly, addressable fire alarm systems provide more detailed information about the location of a fire, allowing for a faster and more targeted response. Secondly, wireless fire alarm systems eliminate the need for wiring, making them easier to install and maintain. Thirdly, multi-sensor detectors can detect multiple fire characteristics such as smoke, heat, and carbon monoxide, reducing the risk of false alarms. Fourthly, artificial intelligence and machine learning are being used to analyze fire alarm data and identify potential fire hazards. These technological advances are helping to make fire alarm systems more effective at detecting and preventing fires, ultimately improving building safety.